Okay, so this is the last question on the potential energy, kinetic energy question with the Roberts. This is question 5, the commuter that's driving a truck. It says that they're driving at 10 meters per second, and they accelerate their truck until they get to 30 meters per second, or 108 kilometers an hour. Now, this is not the heaviest truck out there, because that's only a 4,400 pound truck, and there's a lot of vehicles that actually top out at 6,000 pounds, or roughly 2,800 kilos. So what would happen is, of course, those would use more energy. So let's just figure out the amount of energy that's actually used to go from 10 meters per second to 30 meters per second. So we need to find the amount of work that's been added. So how much positive work has been added? We look at the work kinetic energy theorem, which is delta EK. So EK2 minus EK1. The EK2, 1/2 the mass, 2,030. We have to remember to square this. That's the thing that happens where people forget. Must square that. Minus 1/2 of 2,000 kilograms. And then you have 10 meters per second squared. So of course this is 900, and 10 times 10 is 100. So when you do your calculation, make sure you're aware that 30 times 30 is 900. Of course your calculator can do that. Oh, so 1,000 times 900 would be 900,000 joules here. And then 1/2 of 2,000 is 1,000. 1,000 times 100, of course, is 100,000. And now you have the work is equal to 800,000 joules. Now the question is again about the number of Roberts that you would need. We're going to have a lot of Roberts in the back of this pickup truck. So number of Roberts is equal to the work divided by the energy per Robert. And of course we have 800,000 divided by 45,000. So we're going to be roughly 20 Roberts. So it is 17.77. So 17.7 Roberts. If we round, 18 Roberts. And that would be very hard to get 18 Roberts in the back of a truck powering the truck. So again, it's a lot of energy that we require for our vehicles.